This will be my last presentation. Afterwards, I'm out of business, you heard. So the part where the data engineering is needed is gone. The 60% I usually do with Oxalina's help and the cloud from Google. Then on top of that, I've learned that BigQuery ML will replace my data science work. So what is there to do for me in the future? Actually a lot, and I would like to show you some concrete cases. That's why hands-on data science I was helping a lot of companies with. The two of them that presented today were part of these, and I will show you in a second what I helped them with. So a short introduction to myself. That's me, a lot of sushi, a lot of traveling, 10 years of paragliding, founded my own company, Revolytics, so it's a combination of revolutionary analytics, catchy, hopefully. I like to visualize stuff, just one click away here. I love to do such spiral graphs, just give you some visual thing about me. Please close this one now, thanks. Good. But the main reason I am here as a data scientist, I would like to tell you a little bit about what's the role of a data scientist if you don't know yet. But probably, and I think this one speaks for itself, that's the view that many people can have on data science. So it's a mixture of rather starting from the left, very advanced stuff that people think I do. Society thinks I'm controlling the bad guy in the background doing all these things with Facebook and stuff, data. What my employers or my clients think I should help them do is do boring charts, KPI charts. I do that really. What I think I do, I hope, or I love to do more of that, is this advanced machine learning stuff. And what I actually do, that's a fact as well. I do a lot of select from a database. And as we heard today, it's getting easier, and I quickly want to tell you how much easier that is. It sounded all good and nice, and you were questioned about, is that really the case that you get rid of the data engineering part? Just let me tell you two cases for Flaschenpost and Perfect Hair. I did clustering analysis, but it doesn't matter what I did, it's just I need data to work in my job. I need all the data for my client. So getting the data for an analysis takes me, or took me in these two cases, 4 days. And this sounds stupid and too much time because the offer was for 7 days. If I spend 4 days just bringing together the right data, it's really a waste of money. But that was really the case. For Perfect Hair, we needed 4 iterations to get the right data because there were different systems, and I'm not talking about the future now that you have seen in the future everything will be on Google Cloud. No. 3 years ago with Flaschenpost, 1 year ago with Perfect Hair, there were several systems. I get data, I get it on an FTP server, I need to join them, the IDs don't match up, so everything that will be solved in the future, and my job will be reduced by 60%. So is that bad? No, for me it's brilliant. I can focus on the interesting part, on what I think I do best, hopefully, and focus on the insights rather than getting the data engineering part right and getting the data quality in order. So just as a little background and underlining what you have heard already. So for me, the point about 85% of projects failing is typically people invest in analytics. So in this picture, the idea is the data is the new oil. So what can you do with oil? You can do nothing. You need to refine it to clean the data. And then once you have the tools in place, analytics, you can really get data-driven. So analytics is like a combustion engine. With the refined data, you can do something. But that doesn't end there. So if you just have data and analytics, that won't bring you success. So it's another 2-step at least. You need to understand what data-driven means. So for me, it's rather the scientific way of measuring your success or optimizing your use cases. You want to achieve a goal, you measure it, you see how much and how good you achieve your goal. That's sort of the data-driven approach. It's leaving the realm of the gut feeling, going to the area of getting the data before you execute your actions, get the insights first, and then get the payers on the street, so to speak. And even then, if you have a team that knows what's data-driven, has the data in the right shape, has the analytics tools, the next thing you're missing probably is a roadmap, what to focus on first. And I think there I can help my clients to not start with deep learning and image recognition, but start small with your transactional data. There's really much to find out, and I will show you a concrete case about your customers just by looking at the transactions. So the way to success is not only tools and data, but also insights about how to get data-driven and have a clear, measurable goal to achieve your success. So, not to brag, but those are some of my clients, and that's my background, and I would like to give you some reality check or insights about these clients. So as you can see, some onliners, some retailers, banking industry. So when you speak to them or when you hear them talking about big data, data science, analytics, then it's rather to be in that picture again. They do big data, they invested a lot in analytics, they are data-driven already since years. They just do the cutting-edge technology stuff. But actually what I see, and I saw that 3 years ago with Facebook, or when I started my company, a lot of my clients just dump their data on my desk and ask me, what can you do with that? Or worst case, I need first to find the data inside the corporation, if it's a bank, talk to the right people, and then it's always the question, what can we do with the data that we have? So the picture from inside, so this is the external view, the inside would be a bit different. So many struggle with too much data or data in silos, especially the banks are hurt by this fact. They have the wrong tools, they invested, but overpowered, no skills to use them. Or they say, we invested a lot, but essentially meaning, we did a bit of analytics on the side. So it's not really the core priority to get data-driven, so we frankly invest, it's in vain anyway. So I think one of the most important things I can see is a lot of lack of skills, that they now have a strategic goal to be more data-driven, but have no clue how to get there. So that's the end then, that usually they do something, but are not measuring the success and just do something for the sake of it. And that's exactly not what you should do. Find a good business case, a simple one, measure your success, measure your uplift, does it really impact, and then continue from there, and always learn on the way. So to be more concrete here, I brought you this one. It's one of the analysis I do a lot with my customers, because it's quite a simple one to start with concerning data. You don't need that much data. And it happens that I did the cluster analysis for both. As I was saying, I did cluster analysis for both Flush and Post and Perfect Hair, and I quickly want to go through the steps that is needed so you have a clear understanding of one particular data science job or a project, and the benefits you see, what the outcome is of this. So for who of you did already or knows the topic customer cluster analysis? Is that new to everybody, or who knows? Hands up? Okay, just great. So essentially what you're trying to achieve is get to know your customers better. So let's see if you have a customer base of 500,000, and we heard about product ranges of 20,000 products. It's really hard to get a clear understanding how to group your customers. So that's essentially the outcome of a cluster analysis, is to group your customers into groups that you easily identify with attributes like this was for order fiercely, just a pitch, and then to explain what they get out of it. So the dimensions here are the customers in this group buys books and e-books and e-readers, and movies and so on. So you name the dimensions, I provide you a grouping that is ideal in the sense of you have a clear picture afterwards, all these customers sitting in this cluster, by 80% of their purchases were books and 10% were music and movies as well. But they didn't buy any e-readers, any e-books at all. So this was just the bluish cluster. And so that's the goal, to find your typical customers, or like the personas. Maybe you know the personas. That's rather the gut feeling approach to say, okay, I think I have young people, I have old people, I think I have women, men. That's a clustering of your users. But this one is, the outcome is of a data-driven clustering, can look completely different. So again, that's the goal, and to see that it works, or what you get, if the result is correct and good, is clear groups of customers. So you can say 20% or 30% of my customer base is in this cluster, which has very specific features that compared to the other ones are not similar, but really different. So this cluster buys 80% books, but the other ones, or let's say this one is specific. You have one customer group that is 25% of your whole customers, so these are thousands, that usually, or in the history of the last 3 years, bought 68% of ebooks. So that's an insight. What would you do with that? Yeah, you target your customers better now. Before you send everybody e-reader flyers or online newsletter with stuff about ebooks, now you can really focus on these, and you can be sure that if you target these with ebooks, but not this one, you lose nothing, because these don't buy ebooks. Is that clear, that visualization? It's really, once you have the solution, you see it, it's obvious that it should work, because that's the history of the last 3 years. But to get to this point, to have this insight, that's the tricky part. And that I would like to show you how that's done. So again, what do you search? You search for a grouping that is, in itself, the group should be very homogeneous. So the people inside the group must be similar in age or whatever dimension you choose. So are they book lovers or are they movie lovers? But once you group them, they should be to the next group, multiple groups, should be very distinct. So then when you target them, there's no overlap, possibly. So in this picture, the grouping will be these baskets. You see clearly different, but inside the basket you see homogeneous, similar, not perfectly the same, but similar, in this case, fruits and vegetables, but you get the picture. That's the whole goal, finding a grouping that matches your two requirements. Homogeneity has to be good, and the heterogeneity between them, they need to be different. So how do you do that? So again, coming back to the example, you have an e-shop, you have a retail shop, you have even working in the finance industry, you have the same problem, but probably not as many products. It's always the same. You have, if you zoom in here, you have products and you have customers. Products are from Perfect Hair, thanks for that. Just copying. The customers are just fake profiles generated. But you get the idea. You have on the left-hand side the customers, and it's individual persons, and you have the products that they bought in the history, let's say, the last 3 years. So now you have a mapping between every customer and every product. And a profile of a customer would be, this woman bought a nail polish 6 times, and this product 5 times, so that's her profile for the last 3 years. And now you can start comparing who else in the database is similar to her. So it looks like she bought a lot of nail polish as well, but it's different towards this product. So you see, that's just 20 by 20. 20 persons, 20 products. So find here a pattern is really hard already. Now imagine for Ex Libris there is, I think, roughly in the millions of customers and 2 million of products. So you see this matrix, this visualization it doesn't scale. It's just huge. But you see, people don't buy every product. So you have very distinct selection of products that they buy, so you should be able to group them, if only you could look into 2 million people. So that's where the traditional analytics approach breaks. And there is where my job as a data scientist, I would call that advanced analytics, starts using machine learning tools to find clusters in such data. That is really trivial. If you think about it, it's 3 sources: your customer ID, in the center are the transactions, how many, and on top is the products. The little problem that arises is next. This was just a visualization of, if you would have every person as a dot in 2 dimensions, it's really hard to spot clusters. Let me show that quickly here. It's interactive. So let's say I have 10, just make the case again. If you have all your traditional tools like analytics, you have 2 dimensions you can explore. You can draw every point on 2 axes and see, do I find any clusters? Can I see in 1 dimension, oh, these are all my customers on this dimension, English books. Here, a bit better. Here I see starting, could be a cluster. Just saying, with 10 dimensions, the combinations are 100. And if you scale it up in these millions of products, it's not possible. Even if I show you the solution, the 5 cluster from before, you hardly find them by selecting the right dimension. It's all interwoven in just 2 dimensions. So imagine that in hundreds of dimensions. So just making that point quickly. Going back to the presentation. As I was saying, it's quite easy what you need, but it's on the left you see the customer data, so the typical Stammdaten like the age, is he online, theme, language, and so on. So you know these. The second one is your products. And these are usually grouped because you don't look at each single product as a dimension. Because in the case for Perfect Hair, we had really deep hierarchies, so 4 or 5 levels of hierarchies. If you start comparing your customer on individual shampoos, it's really hard to get patterns. So you need to cluster first, or discuss with, that was 2 or 3 workshops, find the right balance between having a lot of products, and if I provide you insight about single products, you can't act on that. So you rather search to find a balance between, okay, these are our main categories, and if we know the people are likely inclined to buy in these categories, it's even easier for us than having single products. So that's a lot of my job, is working together with my clients and finding out that's the business knowledge I need to bring in. So just providing me the data wouldn't help in that case, because I need to find out what's the right balance. And correct me if I'm wrong, but there were at least 3 workshops going through Excels and drilling down on your categories, and that took a lot of time as well. But just saying, you can't escape that one. That is really part of the deal, working together with the data scientist. You need to explain him how your products are structured. And below, you have I've shown it already, the transactional data. That's quite easy. Once you have it in a level you like it, so let's say this is the main category, then you have just 1 column with more hits. If you go further down, you have 1,000 hits on these categories. I think that's quite simple. Then, there are some trickier dimensions. Here's an example of a bookshop. They have 1 category. Every product has a median index. So was it a hardcover, softcover, was it a film? So sort of you have this categorization in 1 column as a label. And I can't work with that data. I need to, every value is for me. So let's say I as a customer buy 2 books, 2 movies and 1 calendar. So it's not that this product, I need 2 columns to represent these purchases. So every value here actually is an indication of how many products I bought in that category. So you change the, it's not vertically, but you need it horizontally as features, and how far you go down is again a topic for workshops. We did that for brands in your case, so brands are interesting as a dimension, but where to stop? Do you take all these 500 brands, or do you focus on the top 100 or top 10? So this is feature engineering, and this is not, you can then say, okay, these labels are covered by 88% of customers, or we have 38% of all articles are in that category. So you have to find a balance again with how many of these labels you take into account. We usually end up with 300 dimensions that we started to use for then the clustering. So now the interesting part, hopefully, if you have never heard what's inside the box of machine learning, that's exactly once I have discussed with the client, and that takes a long time, then my task is done in 1 day. So that's the small part. Once you have all the data in one place, once you have decided on the dimensions, my part would be, I need to define a distance now with all these dimensions. So the question for me is, how similar are two customers? So for example, one woman, with all the purchase history and all these dimensions we seen before, how's the distance? How can I measure that? Or young versus old, it's tricky. Is it in years? Is it how many purchases? Is it, we discussed that with Perfect there, should we count how many times an item was bought, or is it the revenue? Is it the margin? So you can define with all these dimensions, you on top need to define a distance measure, how similar your customers are, or a measure for the similarity. And that's the tricky part. Usually I go with the simple one to see how far you can go, but just saying that's one ingredient you need. And the next thing is, you need to optimize to find a combination of these clusters. Again, every point in 2 dimensions is a customer. So I don't do that manually, but I need to input in machine learning, in my algorithms, exactly that. I need to define the distance measure. As we've seen before, the distance is the similarity. So if I would do that by hand, I would calculate now, okay, how do I need to set the center of these groupings right, that it minimizes all the distances to the center. So you see, if that's the center, that's a good solution, I guess. So if you would have only 2 clusters here, the cluster center would be here, and the distances to the center, to this center, would be higher. So you measure this sum of all these distances. That's essentially what in the background is done. But I have to define that, which measure I take. And again, another ingredient, that's the last one, I guess, no, second last one. So what you want to do is minimize this distance, overall distance. So again, overall distance means they are very similar if I can cluster them in groups that are similar. If the people inside are similar, the distance are small. So the output of the algorithm is then, if I take 1 cluster, not so good, 2, better, and it gets better and better the more clusters I use in my analysis. So if I would have as many clusters as customers, that would be perfect, but that wouldn't help you a lot, because you then have a personalization system that you can't target every individual person. So it's, again, finding a balance. Once these, it's called elbow method, once this flattens out, that you don't gain more by adding new clusters, then you should stop. Then you have your optimal solution. 4 could be 1, or 7, or 9. So these are configurations where this measurement of the distance, the similarity, is optimal in this situation with this data. So then, or I even give you one more what's to be done. There are different algorithms to optimize different data. So again, if I get data, I have no clue how the data looks, but it could be that the data, and just think again, now we have 300 dimensions, just look at 2 of them. Probably you think data looks like this, like these little dots and clusters, and the whole idea of an algorithm is then finding the right combination that matches optimally. So I choose the right algorithm to find the right output for the right data, but just be aware that's just an assumption you made that these are all little nice clustered already data points. It could be that it's really circular or in many dimensions really complex. I don't see that. That's why I usually just go through a bunch of these algorithms, and the one that outputs the best solution, which is then again measurable against each other, that is the winner for this data set, and I'm happy I found the solution, the best solution for the data. And in the end, that it works, I present you a real case here. Don't name names, but again, we found here 12 clusters, and you instantly see that this cluster or the user in this cluster behave differently. So once you have the solution, you clearly see, okay, this cluster in this dimension has huge impact, or buys much of 90% of the purchases are in this dimension, versus this group that is in a different dimension, again, roughly 90%. So this is the insight that we before discussed. Once you have that insight, you can act upon, you can upload it. We did that with Flaschenpost with this PMML case in 2017. You can even automate that completely once you have that output. And just to give you some numbers, this took me between 5 and 10 days to accomplish, with all the downside of having first to aggregate all the data. So it could be done in 1 week only, once we have the data all nicely stored on Google. And also the ID mapping, the deduplication of customers done. So once that's in place, I would say it's a huge, you can focus on the interesting stuff, finding more dimensions, discussing longer about which dimensions could be interesting. But my message here, it really works. I showed that with 2 customers. I did that also for Ex Libris and Revolytics, and there were some really interesting talks afterwards. So for Revolytics, it was Ex Libris was really a positive feedback. They told me, listen, no agency could tell us that before, that we have not a typical ego shooter gamer. So you have these personas again, young guys, single games, these first-person shooters. No, we clearly saw that's not the case. And they told, yeah, why is that? It looks like they buy books and games. Okay, and then we looked at the gender, and it was clear that the games were bought by women together with books. And once I realized, okay, it makes perfect sense, because their offering changed from ego shooters to family-friendly games. So there you have it. The mother buys the game for the children. And so they focus completely on the wrong target group by just selling stuff or trying to sell stuff to the ego shooter gamer. But once you know that, you can focus on combining books and games. So that's one nice anecdote, because usually I find clusters that you have in gut feeling already, 2 or 3 of them, but the other ones are really outliers you wouldn't expect. Like, Revolytics was the manga buyer. So there was 1% of all customers buying mangas. It's not much, but they have huge revenue. So they buy mangas and mangas and mangas all the time. So once you know that, you can really focus on providing them with a better service, or try to change their behavior as well if you like that. But it was clear it's so much simpler if you focus on these manga buyers providing a new mangas. Stupid, easy. But the way to there, just saying, is via machine learning. I can help with that. I need input, I need data, I need to speak with my customer to get the dimensions right, but in the end it works. And just saying it doesn't take such a long time, and the insight is really, it's deep, I would say. It's a starting point to discuss that. For Flaschenpost, we started with just the clustering, and then drilled down further into the price sensitivity of these clusters. Once you have the clusters and know more about what they want, you can focus on what they are ready to buy, or how much they pay. So that's the next step you could do. It's just the starting point to understand your customers better, and you only see what's been here in the past, so you can't foresee the future changes, but at least you know what they bought so far and you can act on that. Okay, that's my part. If there are any questions, happy to